applications. So in case of system restarts, suppose in case of memory issues, so or anything, how to perform the restarts here? See here almost only 3 GB only is available. 3 GB only is available. Almost all the database occupied. HANA is the in-memory database. In-memory database. So that's why ECP is a lot of data. That's why it's occupied all the data. And also one more S4 HANA DB also tenant also running on here. That is the reason it is occupied. So now what I'm going to do the restarts here. Here to perform the restarts. So it restarts in the either Windows or Windows simple MMC. We can use it MMC console. We can use it to perform the restarts. But if it is a Linux systems, we don't have the MMC, right? In that case, how to perform the restarts? So how to perform the system restarts here? How to perform the system restarts? So Windows, so MMC, right click on the MMC. So then we can SID and stop and start restarts, we can perform it. But especially for the Linux systems, we need to use the commands. So we need to switch to the SID ADM user, SID ADM user. So then we need to stop the SAP first. We need to stop the stopping. If you want to stop the system, the sequence is you need to stop the SAP so you can use the stop SAP all. So which means if we use this command, it will stop the first it will stop the application server, app server, then it will start the ASCS instance, app server and ASCS instance, it will stop it. Then, so DB, you need to stop it here. Then for the starting procedure to start the data system, the reverse order. So DB, you need to start it. Database means we know, right? HDB start, then it will start it here. HDB stop, it will start it. Then on top of, you need to stop the start SAP all command here, right? So kernel version, uh, if it's the above version, is the S4 systems and everything, we need to use the SAP control command. We have to use it. SAP control command, we have to use it. But here we need to use the, so it's the kernel version is the 754. Then we can use the, so we can use the start SAP all, stop SAP all command. We can use it here. Then switch to ECP, right? ECP ADM. So then once you switch to the ECP ADM, you need to use the stop SAP, start SAP command here. But you observe, see here, they are the few users already exist in the system. They are the few users already exist in the system. They are working on the multiple things here. So in that case, they may face disconnection issues here. What I'm going to do, I'm going to keep a system message now. I'm going to put a system message here. So here in the system message, I will inform. So hi all. So ECP system will be restarted in 5 minutes to clear the memory and fix the SQL errors. So like that, so just I'm informing to everybody. So just I'm sending done. Okay, so done. So just wait some time, then just you can just go to stop SAP all. You execute the stop SAP all, it will stop the application server. See here, it is checking the database. So it won't stop database. There is a order stopping the application server first. Then, so then it will stop the ASCS instance here. Then DB, we have to stop it manually. In case of we want to stop individually, then you can use the stop SAP. Suppose if you want to stop only ASCS, then stop SAP ASCS instance number. Then stop SAP if you want to stop only application server. Stop SAP then only that application server instance number you need to use it here. So stop SAP command, right? ASS and application server got stopped. So now I'm going to stop the database as well here. See, once the SAP stopping will not release much memory, right? Still 59 GB is used. So I'm going to stop the database as well here, right? HDB ADM here. Then stop the HDB stop. Same we stop and start the databases, right? Similar way, I'm going to stop and start the database here. So when you are stopping, what will happen? Whatever the memory used here, 60 GB, whatever the memory used 16 GB, all the 60 GB memory get flushed out. Flushed out means it get free. It will come to the zero. Then you can start the freshly, you can start the SAP here. The problem is this is the HANA database. So see, ECB application server is shut down. So session got disconnected here now.
You were doing stop all, so why do we have to shut down database ourselves?
In the same host, we have the DB also. So DB only using the much memory. So since the errors are related to the SQL errors are related to the database. So if you just to have the some memory, if you do the frequent restarts, so then it will be speed, and also if any memory issues or any other issues that will be fixed as part of the restart. So on the same host, we have the DB and SAP also installed. So that's the reason we are doing the restart. Both entire system we are doing the restart to flush out the to get the some memory and everything. So we are doing the restarts. See, it is immediately not stopped. Why? Because it is what it is doing here. All the memory is getting reloaded to the from main memory. Means the main memory, RAM memory to disk layer. It is getting loaded. Disk layer, it is getting reloaded. It is getting loading. So that's what it is happening here. So then once everything, all the data got moved to the data folder level at operating system level, then it will comes to the stopped status here on our database.
So this loading to the disk layer doesn't mean that it is writing to the database itself, but it is just writing an image of the memory, right?
Writing the table entries and data, entire table data from main memory to the disk layer. Disk layer means your slash and a data folder level, it is writing all the data. Why? Because main memory is the volatile memory. So whatever the data is there, it will be stay. System is up and running fine. Whenever you restart the system, stop the system, all the data will be gone. All the memory, whatever the data in the memory, everything will be gone. So that's the reason. So it will be writing before completely dumping to the completely shut down. It is dumping the whatever there in the main memory. Everything is dumping to the your data folder level at operating system level. So this procedure is called the save point mechanism actually. Save point mechanism in the HANA database level. In the HANA, so we have the one mechanism actually, save point mechanism. This is the restarts. So if I talk about our same topic also today, so delta merge and save point interval in the HANA database here. So delta merge. So what is mean by delta merge here? So delta merge is a concept SAP introduced is to avoid the loss of transactions. The main memory is divided into this is the RAM slot. Just assume this is the RAM slot here. So the main memory is divided into the two types here. One is the delta storage DS delta storage. Second one is the MS main storage here. Delta storage and main storage here. In the main storage, we have the actual data resides, actual committed data, actual committed data, committed data, completed transactions data will sit in the main memory only. Main memory operations are very costly here. All the committed data will resides here, right? So see here now, phi hyphen g. So it got reduced. It got reduced to the 10 GB. So 10 GB still is there. So let's see what is there next here. What other system process are there? We have the other process are there. And is there any other HANA database here? So no HANA databases. No HANA databases here. So but database occupied. So still some data is there memory. What I am doing, I am going to reboot the host. Just reboot the host operating system. So it will clean up the entire operating system memory and everything. So I am rebooting. So while it is rebooting, what's happening here in the HANA database level? So the main memory is divided into the two parts here, two storage areas, DS and MS. So first of all, anything is data coming to the HANA database level, first it will come to the delta storage. First, it will come to the delta storage level here. So in the delta storage, all the calculations and all the transactions committed commitments. So everything will happen here, right? Everything will happen here. Then once the transaction is committed, then the committed data will go to the main storage level. Main memory is divided into the two parts. One is the DS and MS. Delta storage means, so here all uncommitted data, the transaction execution, the temporary transaction executions, everything will be done in the delta storage only. In case if the transaction is, if the transaction committed, if the transaction is committed, then the committed data will go to the main storage. So in the main storage, all the committed transactions will sit. In the main storage memory, all the committed transactions will sit here. All the committed data will sit in the main memory. That's why main memory usage is very main memory usage. It will show used size it will show with the data here, right? Committed data it will go to here. When it will go, if the transaction is committed, it will go to the main storage level. So main storage operations are very costly as humans they cannot directly write into the main storage level. We as a human systems directly we can write into the main storage level. But if the transaction is committed here, it will go to the main storage level. In the main storage operations are very costly. So why? Because you cannot directly execute the transactions in the main storage level. Why? Because already there is a committed data is available. In case of something wrong, there is an impact for the existing data. That is the reason. So the transactions, executions, compilation, everything will happen in the delta storage level. If the transaction is committed, then it will go to the main memory, main storage level. It will go. Then after that at the OS level also there is a folders are called the slash HANA data slash HANA log folders and slash HANA shared. There are the folders here, right? Slash HANA data 3 into RAM size. How much RAM is there? Then 3 times of RAM size. We have the size here. So once the transaction is committed here, after the delta data will come to the here in the compressed format. The 10x compression technique will be used here. Then the compressed data, committed data, which will move to the main storage level. Here also the compression factor will be applied here. Then once the data committed here, then after 5 minutes, same data will come to the data folder level. So data folder level. So this mechanism is called the save point interval. Save point interval, right? Save point interval. This will happen by default every 5 minutes here. So this mechanism is called the delta merge here. So delta merge here. Delta storage data is merging with the main storage. When the transaction is committed, that time the data comes to the here. This procedure is called the delta merge operations here. Then once the data is here, then same data will go to the data folder level, that we called it as the save point interval. Sir, why again one copy of data is storing from RAM memory to once RAM to and disk level, file system level it is storing here means, so RAM operations, RAM is the volatile memory, temporary storage area only. So as soon as data move to the here, so suddenly something is happens, entire whatever the data is there in the RAM, everything is gone. So that is the reason one copy of data will be stored into the data folder level. Actual SQL data is available in the data folder level, right? So this is the RAM, this is the storage level, one copy of data storing here. Then your data is safe here in this case here. So whatever the data is there, so when actually at what intervals it will write the data to the here. So regular intervals, every 5 minutes, it will write the committed data to the from here to here. Or whenever you are stopping the HANA database, also that time it will write the all the data to the HANA database. Then normal regular in any committed data received to the here. Then every 5 minutes the data will come to the again it will come to the data folder level. So whenever any activity you are doing, that time first it will write the data to the main memory too and data folder level, then it will stop it here. Something is happened in our case as well here. In our HANA database also, same thing is happened here, right? Same thing is happened here. So now let's go to the your operating system level. You did the restart of the operating system. So as soon as okay, I configured as a auto restart, then HANA database is after the OS reboot, HANA got restarted automatically. Automatically, HANA got restarted. That is also possible here. So then HANA restarted. We have the two index servers, two tenants we have, and access engine we have. So remaining process also we have here. So tenants I created here. So we have the index servers, compile server, name server, so access engine, web dispatchers we have in the this tenant database here, right? So this is created, HANA database is started automatically here. So now what I am going to do now, so memory size also you see here 45 GB, it got increased, right? Now I am going to start then what happened here, when the HANA OS reboot is done, when you are starting the HANA database, either automatically or manually, so whatever the data is there here, it's reached. So again, same data will be reloaded to the main memory when you are starting the HANA database. When you start the HANA database, when you start HANA DB, then all the data, whatever the data is there in the data folder, it will be loaded to the main memory again automatically. That is the reason while stopping, it will take some time. When you are starting also, it will take some time to start it because of all the data should be loaded to disk layer to the main memory here. That is the reason. So it is doing here, right? That's the reason why, because HANA is the purely main memory mentality. So which means everything should be loaded to the main memory, then only it will come to the active status here. Then you can start the, you can just switch the user ECP ADM. So then start SAP all, then your system, your HANA system, your ECP system, production system will be started status here. Now it is starting status here. While starting, first ASS will be started, then application server here. Then otherwise, while stopping application server, ASS, starting ASS and app server will be started here, right? Same time, when you are starting, all the data will be loaded to the again main memory. Again, you will get the same data. Commitments will happen here. So here, while starting, there is a order will be followed. What is that order means? First of all, system tables. System tables will be loaded, will be reloaded first. Then secondary indexes will be created. Secondary indexes will be created for that one. Then after that, column store tables means business tables will be loaded first. Then roll forward will happen. Then roll back will happen. Right? So secondary indexes. First, while loading the data, what type of data will be loaded first? First, configuration tables means system tables will be loaded. Then secondary indexes. Then column store tables means business store tables. ANA is the column oriented columnar database. First of all, so but this column table to be stored first, then first system tables will be loaded. Then only column store tables will be loaded here. Then only column store tables will be loaded here. Then roll forward. Roll forward means suddenly you stopped the system, but the transaction is committed here. The transaction is committed, but not saved into the file system level means it will go forward and it will be saved into the data folder level here. Rollback means when you are doing the transaction, the ticket is not booked. So when you are trying to do the payment, so the payment in progress in middle your system got crashed or your transaction got cancelled, then your transaction will back to the normal rollback, then your amount will be credited back to the your account within 24 hours. Roll forward means you booked the ticket, transaction also committed, then while committing the ticket, then you got the system screen like the 500 internal server error, system is not available, server is down, server is overloaded, something like that, which means the committed transaction is completed. Then it will go and book the ticket and it will send the ticket to your email ID. That is the transaction committed. So we opened the IRCTC, then you are trying to book the train ticket and you opened the CET, you are doing the transactions, that data temporarily it will be in the delta storage level itself only. But when you done the transaction successfully, you done the ticket booking successfully, then the committed data will go to the here. Then from here, after 5 minutes, the data will go to the data folder level here. So that is what it will happen in the systems here, right? So
I
here,
think I have two, three questions. I
yes,
just have two questions actually on the same diagram.
okay, you can ask me.
Yeah, when we say that from the delta storage area, when a transaction is committed, the data goes to the main storage, and then it gets written to data file at Savepoint level. So that means we are not writing any archive logs.
I will come into that part. I'm coming to that point
Okay.
only. Yeah, you can ask me the
Then
questions.
second question was,
Yes.
uh, you said about the secondary indexes. So with the HANA, we are still using indexes.
Yeah,
And
HANA,
third question,
not the column store tables. Row store tables, it will create the secondary indexes.
and then okay, so it will, because you talk about transaction here where we are trying to buy a ticket, which is kind of an OLTP system. So most of the OLTP transactions go in not into the column storage but into the row storage, like the conventional RDBMS, the way we use the tables. So how are we differentiating here when it is writing?
Okay. So coming to the your question to answer the transaction logs, right?
But
So
if you
here,
think you will answer these questions later, I'm fine with that.
yeah, I'm going to answer. I'm going to explain the concept. Still, this is not completed. Why? Because as of now, I explained data is writing into the data folder level only here. But what about the log folder here in the HANA database level? So that's what I'm coming to. So give some information on this area as well. So then you will get the, so what data it's writing into the log area. This is called the archive log files. Normally we will call it as the transaction log files here, right? So the frequently write the transaction log files here. So whenever it will transaction is committed here, the transaction is committing here, then before before writing the data to here in the main storage level, so one copy of data will write into the log folder level. There is a log folder at operating system level. Before committing this transaction writing into the main storage level, then safer side it will write the data into the log folder also. The transaction log will be generated in the log folder level here. The frequently accessed the data, what changes have been done in the transaction level, that will be stored into the log folder level. But when it will come to the data folder level, so after 5 minutes the data will come to the here. But before writing to the here, the first data will come to the log folder level. The transaction log will be generated here. Then transaction log will be generated. Then it will commit the data to the in the main storage level. Then same data will come to the, after 5 minutes, same data will come to the data folder level. It will write the data. Actual SQL data will stay in the, so in the data folder level here. So once write the data into the SQL folder level, so then here we will take the backup of the maybe daily backups or weekly. Why? Because this is also in the same system. This is also in the same system. But entire hardware is crashed. You have the RAM is crashed and the disk folder disk also crashed. So entire your data is gone. That's the reason. So daily we will take the backup of these two, data backup and the log backups. We will take into the separate storage providers or the third party providers. We will take this backup into the separately. In case of something wrong, we will pull the backup data, then we will restore it here. That purpose we will do the backup and restore. That is a different concept. So here log folder, all the transaction logs right into the here. So suppose you write the one SQL query, one transaction committed. So you done some changes, some updates, some insertion, some SQL, some select, something is done. That changes, whatever you have done, that changes. First, it will write into the log folder level only. The transactions will write it here. Then then it will save into the main memory level. Then from main memory to data folder level, it will write the data. So that is the transaction log concept here. So in case of something is happens, sir, while committing the transaction itself to the here, system is down. In middle, system is down here. In middle, system is down. So transaction is not committed, we are not sure. But there is a log is there here, archive log means transaction log is there here. So this has some information about this data. That's why the roll forward and roll back statements will happen. Roll forward, roll back means based upon these logs, it will it has some information whether this transaction is committed but not saved, then it will go and save it here. But it is not committed, cancelled means it will go back to the previous status, then your transaction will be in the previous status here. That will happen here. So there is a secondary indexes as well in the, so the row store table. In the database level, we have the two types of tables here. In the database level, we have the two types of tables in the, so in the data folder level, in the data HANA database, we have the two types of tables. One is the system table. Normally, we will call it as the row store tables, and column store tables. In the column store table, all business data sits in column store tables only. Business data, finance data, sales data, all the column storage level, it will store it here. System tables, normally one more name is called the row store tables. So HANA is not only column oriented, it's a mainly column oriented table. Why? Because all the business data sits into the column storage level, but it has row store tables also. But row store tables contains only system configuration related. System configuration related means so the default configuration, user system configuration related data. So without loading the row store tables first, column store tables will not be loaded. First of all, row store tables loaded, then system can assume, okay, all the configuration is back. Then row store table contains the where is the column store table, what data contains, each and every information contained. That's why first systems tables loaded, then secondary indexes is secondary. Whether it will be created or not, that is secondary. But then immediately column store tables will be loaded here. Why? Because column store tables are the business table. All the business data will be stored into the column store tables only. Any questions, anyone?
System tables are more like all the dictionary related data will be loaded there and all the config data will be loaded there.
Yes.
That is understood.
Yeah.
But when we talk about transaction, like a user or somebody is doing a transaction, so that transaction goes into column storage or does it go to row storage?
Column storage. Why? Because that is the business data. He is doing the business transactions, right? So that will be stored into the column storage level only.
But if there is a frequent write, I mean, isn't it that HANA is supposed to use the row storage?
Row store tables only configuration related. Suppose he is doing some configuration related changes, that will be in the row store only. Business data, that will be in the column storage only.
No, my question was more like when you have row storage, the writes are very efficient. In the column storage, you can fetch the data really quick. So you can read a lot of data in very less time. Whereas, because there is no much of write activity going on, so I don't know, maybe
Here is
it's
the default is the column storage and we can make it into the row as well.
Column only. HANA is column oriented, columnar database only. So row store tables also there, but it contains only system configuration related, not the business tables.
Ravi, your point is very clear. I mean, we are just trying to understand uh, that when they say, okay, the data that is frequently read, I mean, or which is used for analytics or which is used for some kind of running some kind of reports, they use the column storage. And if there is a transaction going on, like people are buying stuff from your store or something, all goes through the table storage, the regular row storage, not really the column storage. But anyway, we can move forward. I think we will waste time.
Yeah. Okay. Table level, just business data level, just I am explaining. So that's fine.
Okay, thank you. Thank you.
Yeah, we can see it in the what has been loaded. So we can see it from the, if you go to the diagnosis files, there is a index server. Whenever you do the restarts or something is happens, so index server, there is a data. Here we can see the, so when was the save point is happening here. So where was the save point? So as I mentioned here, save point will happen every 5 minutes once. So if you see here, so today 8181, sorry, 23.1, there is a one save point is occurred. Then 23.6, one more save point occurred. Then 22.56, one more save point. Like see here, regular intervals every 5 minutes, the save point is happening in the index server level. Why? Because all the business data stores in the index server level. So it will storing the data into the here as well. So here it is saving here. Save point, save point, save point. So here we can see that one. When was the last save point happened? So save point level it is happened. You can see it here, right? So maybe 23.6 one save point happened here. Then next 5 minutes, like at the 23, so 11, so 23.11, one more save point will happen here. 23.11, so one more save point will happen here. But which time zone is this? 23.6, yeah, system time is 8.6. So this time zone is different. Okay, okay. This is the, yep, EST time zone. This is the, what is time zone, this one? Okay, this is a US Pacific Canada time zone. Okay. Okay, both are two different time zones here. In the Windows time zone is different, Linux time zone is different here. Here it is showing the Linux time zone. So 23, so 21, so 23, 8 is there now. So now when you wait for 2-3 minutes, then one more save point will happen here. One more save point will happen here. So if any data, any channels, any activation, something is there, then that will come to here. And also here we can see the errors related information as well here. Error related informations, anything is wrong, so that we can see it here, database level here, right? You see here, so there is a disk usage almost over, right? Disk usage almost, it's in the going to the red status, green and amber, then red status. Red means so almost, so say it is over here. Now it's only, I think only 4 GB is left. 4 GB is left here. So I think this HANA database is system is started, our ECP system. So like that we need to do the stop and starts, and also like that we need to so do the fix the errors and the delta merge and save point intervals, how it will happen. So we can see it here. So coming to the
Sir, save point interval is 5 minutes. It is default time, or
default SAP default time here.
can we increase or decrease that one?
Yeah, we can increase it. If you increase it, you may face the performance issues.
Okay, okay.
So why? Because so after 5 minutes, example, you see, example, so 940, okay, 940 one transaction is committed to the in the main memory level. Then 945 it should reach here, right? So 5 minutes gap, it should reach to the data folder level. So but there is a 5 minutes gap, 940 to 945, in between system got crashed. Then your data will stuck here itself only. But main memory is the temporary storage area only. It will, when you restart it, your transaction is gone. Correct? But whatever, whenever you are restarting, whatever the data is there up to 940, same data will be loaded to the main storage here. So which means, which is the data which is not come to in this data folder level. There is a one data which is not reached to the here, but here stuck it here itself only. Before the save point, it will be your system got crashed and your data got stuck here. But that data is there in the log folder level. Why? Because before writing to the here, your log folder level, the data is there. That's why first it will load the up to 940, it will load the all the data, whatever the transaction is committed, which is not saved here, then that will go and roll forward. It will come to the data folder level again. But the transaction is not committed, that you are doing, which is not committed means not completed, that will go back to the original status here. But if you increase the time limit here, so 5 minutes time limit here, 5 minutes to the 10 minutes, then there is a 10 minutes gap here, right? Where data comes to the final data comes to the data folder level main memory. There is a 10 minutes gap here. In the 10 minutes gap means it's a so something, anything is happens. So then again all the data should be loaded, transaction commitment. So there are a lot of things will happen. So performance issues. SAP simply said, so if you increase the save point interval, there is a performance issues you may face it. Performance issues, many things can cause the performance issues. Roll forward, roll back, and data commitments will lately happens. So there are many things will happen. So that's why some people they will change it. Some people they will go with the default intervals. Save SAP recommended intervals. So like that they will go 5 minutes.
Hello.
Okay.
So
Okay.
it is working, Syed. You can see now, now this SPRO is working.
So
Yep,
where do we use this rollback thing?
So system will take care of that point. So maybe we can check in the log file. So roll forward, roll back. System internally will happen. So nowhere it will be written, but we can check the logs in the trace files. In the trace file, we can check the logs, the load statements. We can check it out. If you go to the OS level, there is a CD trace, same, the log file only I am opening here. Same log file only I am opening here. We go to the here, index server trace file here. So if you go to here, same index server, I can also open from my studio level.
Oh, okay.
Here you can see. So here it will be write it here. Data, it will be write into the here. Save point, save point, save point, save point, save point, save point. But you mentioned, right, where can we see the loading the data, everything? There is a loads. There is a unloads. Loads means, so which data loading to the main memory. So which data is loading to the main memory. So above one schema,
And the
there is a
restart.
table. In the table, these are the statements are executing into the ECP. So now it is ECP. It is loading from data folder level to and your main memory. This table's data is getting loaded. You can see the all the tables related data and everything here. So whenever you do something, so we can see it whenever it is reloading, that will be, we can see the here one more transaction, one more entry will be created here. We can see it in the operating system level.
Thank you.
But roll forward and roll back. So roll forward means that we cannot see it anywhere. We cannot see it. That system internally, it will take care of that operations. But what tables data is loading and what tables data is getting unloaded from the main memory, loading from disk to main memory, these things will happen here. These things we can see it here in the loads concept, unloads concept. So table consistency check. So trace log files. So that's why these log files are very important. If any memory issues, you will see the RT dump memory issues. Anyhow, we will discuss this file system level as well. So that's fine.
Hello.
Hello,
Sir, can you please open the diagram?
can you?
Diagram.
Okay,
Yeah, here you said before committing that the data will be writing to the log file, right?
right.
After committing, the data will be writing to the data.
Actual in the data folder level,
Yeah,
actual SQL data, actual data resides here.
yeah,
So then what changes have done in the changes about the data will be, the logs will be written into the in the log folder level. The
yeah,
actual data resides only here, but this is only logs. What changes have been done, that will be there in the /HANA data folder level here. /HANA
yeah,
data,
yeah.
/HANA and log folder. This is log segments are very, very important. So in the SAP also will tell like, please don't touch these log files. Don't delete these log files are very, very important. OS level. You should not touch these files actually.
So, Ravi, at any given time, the log files will only contain maximum of 5 minutes of data, transaction data, isn't it? Depending on what the Savepoint setting is.
Right.
So we really don't write archive logs anymore, right?
No,
Like we
archive
used to
log
do
file
it
will write it continuously. It will
initially.
write it. If any changes are done, if the data.
No, that is fine. So we don't archive the logs, right?
We can
Because we
yeah,
don't need.
we don't need to do that. System internally, there is a archive log backup will run. Archive log backup will run. Archive log will run. That will clean up this logs and everything here. We don't need to do the system internally. There is operations. It will take care of that one.
So when we are doing the system copy, so we really don't have to worry about those archives.
Yes, right. Yes, not required. No need to worry about that one.
And what is
Thanks.
the interval for writing the system log file to from here log file?
Continuously.
Continuously.
On demand continuously. On demand means if there is no operations, then it won't write any log file, right? So if there is a operations, that time definitely it will rust. It will, whenever any commitments happen, that time first the commitment data will write into the here safer side. Then only once it got the acknowledgement, oh, the transaction successfully saved into the log folder. So then only it will go and write into the main folder level.
And log files are keep on increasing or
No, there is
any.
a archive
Yeah.
logs system internally. There is a archive log backup will happen every 15 minutes once. So that
Yeah.
will do the cleanups.
Okay. Once data will be returned to archeolog, then here log files will be cleaned up. Right?
Yes. Once the transactions are all commitments are happens, then it
Okay.
will do the cleanup. So in the
And
SAP
also,
itself, they have maintained the one set here like don't touch these files in this directory. Why? Because these are the seriously will impact your system. Something you delete something here.
and what is the background process? Will do all those things and writing to log files and all writing to the data.
So here we have the HANA processor there, index server, and these
Oh
are the
yeah.
process. Index servers
Mm.
will take care of this, all those things. Index servers,
Okay.
so name
Okay.
servers, all the processing and everything. These 7 process internally coordinate and will
Yeah.
complete the all these background operations and everything.
Okay.
Quick question.
Thank.
Hello.
Yes.
Yeah. So I know you just mentioned that log files, they do get archived every 15 minutes. So if you needed any log files more than 15 minutes or hours, whatever, then you have to um, point to the archive location. Is that right?
Yeah. In case the archive log backups or that cleanup things is not happening, this folder will become 100% full. So in case of it's coming to the 100% full, then so if this folder is full, your transactions will not be committed. Your database will not function properly. So what happens if the
Okay.
cleanup is not happening? If the /ana log is 100% full, there is no space, there is no full, then your database will not function properly, will not commit any transactions. So database will be hung status. Then what you have to do? You need to run the backup. Then if you want to manually run it, then there is no space, it won't run. Then what we have to do? We need to create a soft link to the available where we have the log full situation, HANA log full situation. This situation is called the HANA log full situation. So then in this case, what we have to do? We need to create a soft link to the available directory. Then log files written into the log files, whatever the data is written into here, log files written into the that level, that folder level, it will write it here. So no issues with the commitments. So in case of what happens if you don't 15 minutes, it's not running 1 day, 2 days, that's not running, then log full happen. That is called the HANA log full situation. In that case, our database will not function properly.
Okay. Got it. Thank you.
So, can you explain once about secondary index?
You no need to worry about this indexes. Index part is only as and when required. That time it will create it. So it will create it. So in case of the tables it does not have, that time it will create. Otherwise it will skip this part and it will go to the third step number 3 column store tables will be loaded. Otherwise until unless then it won't directly do daily it will go and create it. When we don't have that time it will create the secondary indexes. This is an optional step for the database operations.
Yes.
What is the for number 4 and 5 roll forward and roll back, and what event are those taking place? So what's happening there? Roll forward, is that going from like what do you call?
So
Is that-
rollback means, as I mentioned here, right? The transaction before committing system got down. Before committing system got down.
Okay.
But the log is written into the here.
Mm-hmm.
But the is committed or not, the log is written into the here. Once all the data are loaded, when the logs are applying to the logs are applying, it will check which transactions are committed. Then it will go and save the database folder level. Which transactions are not committed, then it will go back to the previous status. Previous status means original status, not booking status.
Okay, so it doesn't have to go to the main story at that point when it's going to roll forward.
Yeah.
Directly to HANA data disk folder.
Right.
Okay, yep.
Okay, so that's it for today. So we'll talk tomorrow about the